look at part C. Now the last way that we can show sensitivity is we actually draw a graph. Now in fact, if you look at it, CVP, like your break-even chart, is also a way of showing sensitivity. But usually break-even chart is to show sensitivity of your volume okay. Break-even chart is to show sensitivity of your volume. That's why just now when we calculate the sensitivity of the volume, we understand that 5,000 is target, 1875 is break even. That's why when you sell 1875, you got no profit. So the difference from target to break even, 3125 is the sensitivity, or we call it as what? Margin of safety. So actually this is break even chart if you realize it. Okay. Now but the only difference is when we do break even, we only look at sensitivity of just the volume. But we can actually look at different types of sensitivity. Now for example, draw a graph that shows sensitivity of the selling price. Okay. Now lamp. Okay. If you sell at 50, just right here lah. If your selling price is at 50, your profit is, just now we calculated how much? 100. So if you want to draw a sensitivity of the selling price, that means you expect that this is your selling price, then the amount is here. So if your selling price is 50, your profit is 100. Okay. Now, at what price you break even? The selling price can reduce to 30. That means 50, if you drop to 40, drop to 30. Let's say if you drop to 30, then your profit becomes 0. Now, so if you draw this in a graph, okay. $10, $20, $30, $40, $50. $50, $100, $50, $100, $150. Now, at the price of 50, your profit is 100. At the price of 30, you break even. So if we take these 2 points combined, now this graph measures the sensitivity of your selling price. So how much is the loss when we have 0? See, some might be thinking that, I thought when the thing is 0, the loss is a fixed cost. Now you must understand, this is not volume. Volume 0, that means you don't sell at all. Then your loss is fixed cost. This is you are selling at 5,000 units, but you're selling at different price. If you take 5,000 units, sell at $30, you make no profit. If you take this product, sell at $20, this is the loss you're going to suffer. Now, if 0 means the 5,000 unit you give for free, understand? So here is to give away 5,000 unit FOC. Because it's based on 5,000 unit. So if you give away 5,000 unit for free, at no charge, your variable cost is 18 times 5,000. Your fixed cost is 60. So it's 150. I scale a bit out. Okay. That's why your loss is 150,000. Okay. Okay. That's it. So this is how we prepare sensitivity analysis. Okay. Page 55. See an example. Okay. The requirement starts in 56. Now they want us to calculate what is the expected value for the profit from the dinner and dance project. Requirement is 56. Okay. Then they say B, recommend with the supporting financial and cost data whether or not the charity should spend 400 on market research inquiry and then the benefit that this inquiry could provide. Now all working for ticket should be in steps of 100. Advertising is in steps of 8. Okay. For the past 20 years, the charity has held an annual dinner and dance with the primary intention of raising funds. Now this year there is a concern that an economic recession may adversely affect both the number of persons attending the function and advertising space that will be sold in the program. Now, they're going to do annual D&D, okay? So now there are two things that they are not sure. How many persons attending and the advertising space. This one, not sure, not sure. Now, when one thing you're not sure, then it's a simple expected value. But when you have two or more things you're not sure, you have to use joint probability. So you must understand that, okay? So when you have two or more things not sure, then you must use joint probability. Now, based on the past experience, the current prices and quotation, it is expected that the following cost and revenue will apply. Okay, for dinner and dance, they spend 700 to hire premise, 2008 for band, 800 for raffle is lucky draw, okay, 200 for photographer. Food, it will cost 12 per person, but guarantee minimum is 400. Fixed cost is 2005 plus 5 per page. This is D&D, this is program. You know the booklet you have in the event, okay? It's called the program. Okay, revenue wise, they will charge for the D&D, right? On average, $20 for ticket, $4 for raffle, $1 for photograph. That means one person must pay 25. And advertising, they charge 70. So a subcommittee formed to examine more closely the likely outcome of the function discovered from the previous record and account, the number of tickets sold. Now, these are the tickets sold. These are the occasion. So if you know 4 out of 20, then you know the probability is 0.2, 0.3, 0.4, 0.1. But then the ticket sold is like that one, 250 to 349. Then how to calculate all? Because you want me to agak how much profit I can get, then at least I have one number, okay. But now you tell me 250 to 349. How you supposed to work it out? That's why just now the requirement say the working for ticket is in the steps of 100. So how do you make it in the steps of 100? Now when we have a range, our solution is we take the midpoint. So 250 to 349. If you take these two numbers, add, divide by 2, you should get 299.5. That means we will produce based on 300 tickets. Is the midpoint, okay? Then this becomes 400, 500, 600. Now then the program pages sold is 24 or 32 or 40 or 48. Now it's already in the steps of 8. That one don't need to average. Just take this figure, okay? So again the occasion also 0.2, 0.3, 0.4, 0.1. Now, so in this case, how many possible outcomes you're going to get? You're going to get 16 possibility, 4 by 4. Now for example, 300 ticket, 24 pages is one. 300 ticket, 32 pages. 300 ticket, 40. 300 ticket, 48. That's 4. Then you try again 400 with 24, 32, 40, 48. So it will be 16 in total. Okay. Okay. Several members of the sub-committees are in favor of using market research consultant to carry out a quick inquiry into the likely number of tickets sold and pages of advertising that were sold this year during the dinner and dance. Okay, come back to this. Now, we have 16 possible outcomes, okay? But the 16 possible outcomes come from 4 by 4. The first 4 is the ticket. The other 4 is the program pages. Okay. We first estimate now how much from the ticket sales, your profit and loss. Now we look at the revenue first. You charge 25 per ticket. So if 300 times 25, you get 7,500. Then 10,000, 12,500, 15,000. Now what costs we have here, I will group all the fixed costs together. Fixed costs. Now this fixed cost made up of 700 plus 2008 plus 800 plus 200. The 4 amount are just the fixed cost. Okay, besides these 4 amount fixed costs, then I don't say variable cost. I'll just put as food. Food. The food is semi-variable. Correct. It's 12 per person, but minimum 400. That means here it will still be 4,008. Here also 4,008. Here 6,000. Okay. So we make a loss. $1,008. profit 700, 2,000, 3,003. Okay. Now, so this is what you're going to get based on ticket alone. Okay. What about program pages? 24, 32, 40, 48. Now these program pages you charge 70 per page. See, the variable cost is $5 per page. So 96, 160, 200, 240. And then the fixed cost is 2,005. So in the first case, your loss is 916. Followed by another loss 420. Profit 100. Now, so the expected value of the project. So how do you get the EV of the project? See, I can have 300 ticket and I also have 24 pages, so I make a big loss. Okay, so if I have 300 ticket, 24 pages, I will have a loss 1,008. Plus 916. Now if I have 300 ticket and 32 pages, I also make loss 2220. If 300 ticket, 40 pages, the loss is 1,007. 你 get 啊？错了，96块，哪一个96 ？5 times 24 is not 120 sorry 120, so it's 940 Then my loss is 1,007. Sorry. Now if 300 ticket and then 48 pages, I also make loss 1180. That means if my event only got 300 tickets, so then all definitely will be loss making. Okay? Whether the loss is bigger or smaller, affected by the program pages. So, alright. Now, if I have 400 tickets and I have 24 pages, I also make loss 240. 400 ticket, 32 pages, profit 280. 400 ticket, 40 pages, 800 profit. 400 ticket, 48 pages, 1320. Now if it's 500, 24, then we have 2,000 minus 940, 1,060. 532, 2,000, 540, 2001, 548, 2,620. Now with 600 ticket sold, 24, 32, 40, 48. 33 minus 940, 2360. 33 minus 420, then 3004, 3920. So that means you can see in this whole project, there are at least 5 out of the 16 possibility you make loss. So if you know that these 5 possibility gonna happen, might as well we don't run the project, okay? But of course the problem is we don't know. Now that's why when we don't know, we have no choice, we take probability to average out the result. So how do you average out the result? We multiply with the percentage. Now the chance that it will be 300, 300 is 0.2. So you times 0.2. Then you times 0.2, 0.3, 0.4, 0.1. Now this 0.2 is for this 24, 0.3, 0.4, 0.1. Then you replace. So when you replace, you change this into the probability for 400, which is 0.3. So 0.3, 0.3, 0.3, 0.3. Then 500 is 0.4. And 600 is 0.1. Okay. Right, so the EV will be $109.6. $133.2. $136. $3.6. $14.4. $252. 96. 39.6. 84.8. 189.6. check my figure. 336. 1048. 37.2. 'Okay. Right. So what's the EV? Anyway, it doesn't matter lah. So from the EV you can get the answer, and then if you find the answer is positive, then you should go ahead. But if you find that the EV turns out negative, you should not go ahead. That means the risk is higher. Understand? Now this is how we evaluate using expected value. Okay. When you look at expected value, you understand that there is still an uncertainty. You're still not sure what's going to happen. Can say not? So that's why you have possibility you make loss, you have possibility you make profit. Now we say before, if there is a consultant that can come to you and tell you exactly how many tickets you can sell, how many pages you can sell, now then only you decide you want to do or not. Now, would that be better? Definitely, right? Because if let's say the guy come and tell me, you only have 300 tickets and you only can sell 32 pages, well, then my loss is 2,002. Then why should I go on? I might as well don't go on. So that's why if there's someone that can come and tell me this information, then I think it's good for me to decide. Now, that information is called value for or perfect information, which is what they ask us in part B. They say that if there is going to be a market research you can spend so that you know how many tickets sold and how many advertising pages you can sell. But you must pay how much? You must pay 400. So the question now is, do you want to go ahead or not? Okay. Now, so how do I know whether the 400 is worth go ahead or not worth go ahead? Now then I must work out what's the value of perfect information. Okay. Now we say before, if you take EV, expected value of your outcome, without uncertainty, perfect. EV of outcome with uncertainty. Now, with uncertainty is existing right now. Yeah. So I need the figure. Anyone got the total? Seven, 6, 8. Okay. So right now, with some profit, some loss, the EV turns out to be 768. So if it's without uncertainty. Now what is the difference when there is no uncertainty? Now without uncertainty, you would have avoided the bad EVs. Okay, that's what you're going to see. You would have avoided the bad EVs. That means you know things are not good, you will not go ahead. Now, if you know things are not good and you won't go ahead, that means these are the 5 you won't see it. It will all be 0. Why 0? Because I won't go ahead. If I don't go ahead, I won't make loss. When I won't make loss, then the negative all disappear. So that's why these are the 5 figures disappear. Now if the 5 figures disappear, you will see your EV will increase back. To 1184.8. So this become value of perfect information. Now since the market inquiry would cost 400, while the value of perfect information is worth 416.8, it is still acceptable. As long as you charge me an amount that don't exceed the value is worth 416.8, so it will still be acceptable. And what would be the benefits? Once the perfect info is obtained, we know exactly how many tickets and program pages can be sold. Once you have perfect information, you will know exactly. In that case, we can make correct decision. So what's the correct decision? That is not to launch. Okay? If the ticket sold can only be 300 tickets, regardless of the pages sold, because that one all 4 make losses one. And if the ticket sold can be at 400 with only 24 pages program advertisement, so because all these 5 outcomes would be loss making. Okay. Okay. So I'll finish off all this exercise with you. We have last few minutes to finish off. So I use this to discuss one last small part with you. It's just to give you an idea. Okay, it's not for exam, because exam also you don't see them testing this. They cannot test, but they cannot test. Okay. Now I'll discuss this thing with you called Monte Carlo simulation. We don't need the notes. I use my example, easier. Okay. Now, why we need this Monte Carlo simulation? Let's say, for example, if I tell you my factory, if one unit takes 10 minutes and one day I work 8 hours, am I right that we have a productivity of how many units? 48. Correct? No? If one unit is 10 minutes, one day work for 8 hours, so productivity is about 48 minutes, no? 48 units, no? Because it's 6 units in 1 hour, 6 times 8 is 48. Okay? Now, but this is mathematics. In real life, your worker will not work exactly 10 minutes. Then your machine may not be exactly so efficient. Sometimes they break down, sometimes workers go toilet, sometimes they're sick. So there are a lot of things that will happen. So because of that, if you accumulate the result in the long run, maybe in 1 month, after you work for 20 over day, with few hundred workers, the difference can become very big. So imagine you thought that if I got 1,000 workers, and then I work 25 days in a month, then I multiply with 48, then I thought this is my capacity. Now 1,000 times 25 times 48, now I thought I will get 1.2 million a month. Now, but what if my actual pure or real capacity is not 1.2? It's much lower. Then how? Then my budget is wrong. So that's why what happened is we need to do a simulation so that we can estimate what is going to be, let's say, the real output, a more realistic one. Now, but before we can do that, what we need is we need to know that if you look at the history, usually one unit, how long they take. Now, 10 minutes is more like an average. Sometimes got 9, let's say. Sometimes got 8 only. 11, 12, 13. So let's say it can be from 8 until 13. But 10 is supposed to be the standard. So if you do like that, then it shows the variation, it range from 8 to 13. So how do you estimate then? Now, that's why we must ask ourselves, how many percent chance that it occur in this way? Now, let's say we have a 5% chance, okay, 3% chance it occur 8 minutes. 5% chance is 9 minutes. 25% is 10. 20% is 11. Let's see. Then 27% is 12. And 20% is 13. So we realize that this is the chance that we see. That in the past, from the record, we realize that the chance that it will be 3, 5, 25, 20, 27, 20. Now this is the chance. Okay? So if you want to see this as a chance, then now the question is, how do you measure this chance? And then I want to use a simulation to reflect the chance. Now we need a frequency distribution. So how do you do a frequency distribution? Now basically I want to give one number to represent one value. So if you got 3% chance, you must have 3 numbers. So I'll give you 3 number. Now you can start with 0, 1 or 0, 0 is up to you. Okay. Now you want to take 0, 0, then 0, 0, 0, 1, 0, 2. If you want to start with 0, 1, then it will be 1, 2, 3. Now then 4, 5, 6, 7, 8. There will be another 5 number. Okay, then 0, 9 until 33. Then 34 until 53. Okay, then 54 until 80, then 81 until, now 100 there's no 100 lah, so we take until 0, 0. That means 99, then we add a 0, 0. That's why I say you want to start with 0, 0 also can. Yes, sir, it's 0, 1 also can. Okay, now, so now we have come up with a frequency distribution according to the probability. So what is the use of this distribution? The distribution will give us a simulation. And how do you get the simulation? Now we need random number. So you just use imagination. I write 100 number that start with 0, 1, 0, 2, 0, 3, 0, 4 until 99, until 0, 0. I got 100 number. I throw inside a box. Then you put your hand inside, you just shuffle, take a number. Now the number you take, there will be one of the chance fall into this. But because like for 12 minutes, you got 27%, they have 27 number inside. So the chance that you can draw a number that will represent 12 minutes, got 27%. The chance you can get a number that it will be 8 minutes, only got 3%. So the chance is bigger because you have more number. So this is how we have that distribution to represent for us the percentage of the probability. So now with this random number, now I don't have the 100 numbers in the box here, so I'm going to use calculator. Okay, so shift random number. Random number is the decimal point. Okay, press equal. I take the first 2 digits. So 51, then I just keep pressing equal. So 51, 95. Now let's say I produce 20 numbers. 69, 30, 30, 10, 68, 86, 70, 75, 93, 23, 5, 60, 29, 67, 20, 63, 29, 28. Now, with only 20 numbers, the pattern will not be as close as what we're going to see here in the probability, because the numbers are not big enough. So you can try up to 1,000, 2,000. So imagine you make 1,000 number one set, and then you check the probability. And then after that you take another 1,000, then you check. You realize that the first 1,000 and the second 1,000, the numbers are different. But once you average out the result, right, it's more or less the same. Okay? Now that's because we are based on the same probability to distribute the number. Okay. So if you follow this number, now you must ask yourself, 51, where is 51? Now 51 is here. Number 51. That means we expect 11 minutes. And then 95. Now 95 is 12, 13 minutes. 69 is 12 minutes. 30. Now 30 is 10 minutes. Another 30, 10 minutes. So it's 11, 13, 12, 10, 10. Then 10 minutes. 68, 12 minutes. 86, 13 minutes. 70, 12 minutes. 75, 12 minutes. And then 93, 13 minutes. 23, 10 minutes. 5, 9 minutes. 60, 12, 29, 10, followed by 67, 12, 20, 10. 63 is 12 again, 29, 10, 28, 10. Now this is my estimate. Now we have simulated the outcome. Okay, so we are just predicting that based on the probability and the frequency distribution, by making use of random number, what will the outcome be? Now you realize or not, most of the unit is around 10, 12, 13, 10. Well, that's because these are the major probability. You have very little probability with 8 and 9 only. Total is only 8%. That's why so far we only see once 9 minutes will appear. Now, so when you calculate like that, then you will know if one day I give you 8 hours to work, these 8 hours, how many units you can make. So imagine you add up the time, 11, 13, 12, 10, 10, 10, you add up. Then you realize that maybe one day in 8 hours, you won't get 48 units. Maybe you only get 41 units or 42 units. Then if you start to measure this on a bigger scale, like maybe you measure for one whole month, then you realize that maybe instead of 1.2, we only can achieve maybe 1.09 million, something like that. Okay. Now this is the example, one of the use of how we estimate something that we are not sure. All right. Now we call this as Monte Carlo simulation. Okay. Now, but anyway, this sort of thing not so useful to you. So that's why it is used to be in the syllabus, but also cannot test on in the exam. How to test? So we just explain to let you know that that's how it works. Now, whatever I've explained to you, the example, long detail one, is in page 52, but with different numbers. Okay, you can read that one. You read all the way until 53, 54, you get the same thing I explained to you. But as I say, if not very clear also never mind, forget it also never mind, because it's not important for exam. Okay, so I think we will finish here today. Alright, thank you.